Hello and welcome to the video presentation of our 2019 Industrial Engineering Senior Design Project. My name is Zoe. My teammates are Max Goldberg, Matt Lubin, and Roshan Rooms. And we are Team 6. This semester we work with Syngenta to double the throughput of their quality test due to their forecasted doubling of demand. Our objectives for this project were to have the current cycle time resulting in doubling the throughput of the current system, improve the overall working conditions of the process, and improve the overall ergonomics of the process. The system we are working on works as follows. First, seeds are put into the canisters, which are placed into the grinders. There, the seed is turned into flour. To prevent cross-contamination, the canisters are washed and then dried.
For our project, we had to work within a few constraints, namely, limited square footage, having the process within a small lab with no recommendations for increasing the size of the lab. Budget, having a $10,000 capital project budget for the 2019 calendar year. This does refresh though, going into 2020. Manpower, having only one shift, a limited number of workers, and a very flexible list of processes to be performed on a daily basis. In evaluating the ergonomics, cycle time, and environment of the lab, our group used time studies and the MTM1 system to make synthetic time studies and record the performance of the operators. We used the RULA and REBA ergonomic assessments to find the tasks that were most stressful for the workers. We also recorded the anthropometric measurements of the operators to find the correct table height for the most people. Finally, we measured the environment with regards to heat, dust, sound, and aisle width to determine compliance to current regulations.
In order to develop solutions, the team first needed a baseline to improve upon. First, the team conducted an observed time study of operators grinding seed, washing canisters, and plating samples. This was followed by MTM1 analysis. These verified that the bottleneck of the process was the drying process. After the time studies, we conducted a series of ergonomic assessments using the same steps that were used in the time study. We were able to identify two major areas of concern: loading the canisters in the dishwasher and the sealing of lids onto the canisters. Finally, we conducted an environmental assessment looking at dust, specifically explosivity and air particulate, heat, sound, and aisle width. The team found no problems regarding heat and dust particulate and sound, and room to improve regarding explosivity and aisle width. For our solution approach, based on the current state analysis, team was able to dial up solutions for areas that Syngenta can improve on. Talking with Syngenta, we came up with an optimal dry time that Syngenta wanted to hit. We decided to experiment with small heating lamps to see how much faster they can dry canisters. Syngenta really wanted to improve dust control and sound in the grinding room. This is when a new downdraft table was suggested along with acrylic boxes to go over grinders to help with this issue. With ergonomic assessment, we found hotspots in certain areas in the lab room and came up with multiple simple solutions to get rid of the hotspots in all areas. One example is lowering the canisters in the dishwasher. We improved this process by raising the table and turning it 90 degrees to face the grinding room.
After conducting all necessary studies and gathering data, we were able to formally recommend a solution to the Syngenta team. First, the installation of food-grade heat lamps would reduce the drying time, the bottleneck, by 33%, allowing them to hit their throughput objectives. However, this is based on an average grinding shift of 5 hours. If the shift is shorter or longer, the team has derived alternative solutions. Along with these, a combination of new downdraft tables, small layout changes, and the introduction of a 5S program will complete the remaining objectives related to ergonomics and safety. With these solutions in mind, the team calculated the economic impact of the results. Operating under the assumption that one sample of delayed seed costs $10,000, Syngenta can expect to see immediate maximum first day savings of $884,950.